Revisiting AI Project Cycle. Let's revisit the AI Project Cycle framework using data science with an example. Before we begin, fill in all the stages of the cycle here to see how much you remember. The scenario. Humans are social animals. We tend to organize or participate in various kinds of social gatherings all the time. We love eating out with friends and family, because of which we can find restaurants almost everywhere. And out of these, many of the restaurants arrange for buffets to offer a variety of food items to their customers. Be it small shops or big outlets, every restaurant prepares food in bulk, as they expect a good crowd to come and enjoy their food. But in most cases, after the day ends, a lot of food is left which becomes unusable for the restaurant, as they do not wish to serve stale food to their customers the next day. So, every day, they prepare food in large quantities, keeping in mind the probable number of customers walking into their outlet. But if the expectations are not met, a good amount of food gets wasted, which eventually becomes a loss for the restaurant, as they either have to dump it or give it to hungry people for free. And if this daily loss is taken into account for a year, it becomes quite a big amount. Now that we have understood the scenario well, let us take a deeper look into the problem to find out more about various factors around it. Stage 1. Problem Scoping. This is the first stage of AI project cycle. In this stage, we closely examine the various factors that cause the problem in order to build an AI-enabled project. The following is the 4 W's canvas for the above problem. Who, what, where, why. Keeping the above scenario in mind, let us fill the 4 W's problem canvas. Who canvas. Who is facing the problem? Who are the stakeholders? Restaurants offering buffets. Restaurants owners. What do we know about them? Restaurants cook food in bulk for buffets every day to meet their customers' requirement. They estimate the number of customers that will come for the buffet in their restaurants. What canvas? What is the nature of the problem? What is the problem? Large amounts of unconsumed food items are lying in the form of leftovers at the restaurants, which is either thrown or distributed for free to needy people. Restaurants have to bear financial losses due to everyday wastage of food. How do you know it is a problem? Market surveys show that restaurant owners are facing problems of food wastage. Where canvas? Where does the problem arise? What is the context or situation in which the stakeholders experience this problem? Restaurants that serve buffets. The leftover unconsumed food at the end of day. Why canvas? Why do you think it is a problem worth solving? What would be of key value to the stakeholders? A correct estimate of food to be prepared every day will reduce food wastage. How would it improve their situation? No food or less food is left unconsumed. Reduction in financial losses due to food wastage. After the 4 W's canvas, let's put them together in the problem statement template. Are restaurant owners who have a problem of financial losses due to food wastage. What? While due to lack of proper estimation, food is unconsumed and wasted. Where? An ideal solution would be to provide an effective system to predict the amount of food to be prepared for everyday consumption. Why? To conclude the problem statement template, goal of our project should be to predict the quantity of food dishes to be prepared for everyday consumption in restaurant buffets to avoid wastage. Stage 2. Data acquisition. Once the problem is identified, the next step is to acquire data for testing and training our AI-based project. For this, we need to understand the kind of data to be collected. The data features are used to define the type of data that needs to be acquired to achieve the goals of our project. In the above example, the data features that will be considered for the preparation of food for the next day buffet for consumption are as follows. Total number of customers. Quantity of dish prepared. Dish consumption. Unconsumed quantity of dish per day. Price of the dish. Quantity of dish for the next day. How will these factors affect our problem statement? The answer to this is the System Maps tool. It provides the relationship of various factors and their impact on the project goal. The following is the system map for the above scenario. Dish consumption, piece of dish, dish quantity prepared per day, total customers, quantity of dish for next day, unconsumed dish quantity per day. The above system map shows the relationship of various data features with each other. The goal of the project is to reduce food wastage. Each element is defined to depict its impact on the goal. An arrow with a positive sign shows a direct relation, and the one with negative sign shows an inverse relationship with the elements. For our scenario, a data set that covers the details of all elements for making a specific dish is prepared by the restaurant. The data is collected over the past 30 days through surveys as it caters to a specific restaurant only. The elements are under the following heads: quantity of dish produced per day, quantity of unconsumed dish each day, price of the dish, total footfall of the day, number of fixed customer, etc. Stage 3. Data exploration. The next stage is data exploration. It is the stage of cleaning the acquired data. Once the data is collected, we extract meaningful information from it to achieve the goal of our project. In our scenario, the goal is to develop an effective system that can predict the quantity of food to be prepared by restaurants to minimize wastage. The following data needs to be prepared for the same: name of the dish, quantity of the dish prepared every day, unconsumed quantity of dish per day. Stage 4. Data modeling. After the data is explored and the data set is ready, the next stage is data modeling. In this, the model is fed with the training data set to see if it matches the desired output. In this scenario, the regression model is chosen. Regression is a supervised learning model, which is used to predict continuous values. In our scenario, the data set that we shall use to train our model is a continuous data of 30 days. We can use a regression model so that it can predict the next values. In this case, the model is trained for the first 20 days and then gets evaluated for the rest 10 days. Stage 5. Data evaluation. The next stage is to test the model if it's working properly or not. The following are the steps followed to test our model based on the above scenario. Step 1. We feed the data to the trained model. In this example, name of the dish and the quantity produced are fed to the trained model. Step 2. To feed the data of quantity of unconsumed food of the same dish on previous days. Step 3. The model then works upon the entries based on the training it got in the modeling stage. Step 4. The model predicts the quantity of food to be prepared for the next day. Step 5. The predicted quantity is now compared with the testing data. From the testing data, the quantity of food to be produced for the next day should be total quantity minus the unconsumed quantity. Step 6. The model is tested with different data sets at least 10 times during training. Step 7. Now the predicted values and actual values are compared to check the efficiency of the model. Step 8. The model is said to be accurate if the difference between the predicted value and actual values are similar. If not, then for better accuracy, either the model selection is changed or it is trained on more data. After the model is tested and is found to be accurate, it is ready to be deployed in the restaurant for real-time testing.